semiconductors. Semiconductors are materials that have a conductivity between that of conductors like metals and insulators like ceramics. The unique property of semiconductors is that their ability to conduct electricity can be manipulated by the introduction of impurities, and the process is called doping. And this is by applying an electric field or by exposure to light or by temperature changes. In a semiconductor, the energy levels of electrons are divided into two bands, the valence band and the conduction band. The energy gap between these two bands, called the band gap, determines the electrical properties of the material. Unlike conductors, where electrons can freely move in the conduction band or insulators, where the band gap is too large for electrons to jump from the valence band to the conduction band, semiconductors have a moderate band gap that allows some electrons to move to the conduction band under certain conditions, thus enabling conductivity. Semiconductors are foundational in modern electronics, forming the basis of devices like diodes, transistors, and integrated circuits. Let's discuss the properties of semiconductors. Semiconductors can conduct electricity under preferable conditions or circumstances. This unique property makes it an excellent material to conduct electricity in a controlled manner as required. Unlike conductors, the charge carriers in semiconductors arise only because of external energy, for example, thermal agitation. It causes a certain number of valence electrons to cross the energy gap and jump into the conduction band, leaving an equal amount of unoccupied energy states, that is, holes. The conduction due to electrons and holes is equally important. Now let's discuss a few important points to be remembered about semiconductors. First one is resistivity, 10 power minus 5 to 10 power 6 ohm meter. Conductivity 10 power 5 to 10 power minus 6 mho per meter. Temperature coefficient of resistance negative. Now current flow is only due to electrons and holes. Discuss about classification of semiconductors. Semiconductors can be classified as intrinsic and extrinsic semiconductors. Intrinsic semiconductors are pure semiconductors like silicon or germanium with no impurities. And in these, conductivity increases with temperature as electrons gain enough energy to jump from the valence band to the conduction band. Extrinsic semiconductors are doped semiconductors with impurities added to improve conductivity. Doping is basically the process of adding impurity atoms to a semiconductor to increase its conductivity. There are two main types of extrinsic semiconductors depending on type of dopant used: N-type semiconductors and P-type semiconductors. In case of P-type, doping with trivalent atoms like boron, aluminum, etc., which creates holes or positive charge carriers as majority carriers. And in case of N-type, doping with pentavalent atoms like phosphorus, arsenic, etc., which adds extra electrons as majority carriers, increasing conductivity. Let's discuss about the intrinsic semiconductors. Intrinsic semiconductors are pure semiconductors with no impurities. The conductivity of intrinsic semiconductors increases with temperature because thermal energy excites more electrons to jump from the valence band to the conduction band, creating free charge carriers. Now about the band structure, the valence band contains the highest range of electron energies where electrons are bound to atoms. The conduction band has the range of electron energies above the valence band where electrons are free to move and conduct electricity. Now, band gap, which is indicated with Eg, it is the energy difference between the valence band and the conduction band. For silicon, Eg is about 1.1 electron volt. For germanium it is 0.66 electron volt. In intrinsic semiconductors, current flows due to the motion of free electrons as well as holes. The total current is the sum of the electron current, which is IE, due to the thermally generated electrons, and the hole current IH. For an intrinsic semiconductor, at finite temperature, the probability of electrons existing in a conduction band decreases exponentially with an increasing band gap. Let's discuss about extrinsic semiconductors. Extrinsic semiconductors are doped semiconductors with impurities added to improve conductivity. There are two main types of extrinsic semiconductors depending on the type of dopant used: N-type semiconductors and P-type semiconductors. In N-type semiconductors, the semiconductor material is doped with atoms from group 5 of the periodic table, such as phosphorus, arsenic, etc. These dopant atoms have one extra valence electron compared to the semiconductor material. When they replace some of the semiconductor atoms, they create extra electrons in the crystal lattice. In N-type semiconductors, conductivity is mainly because of electrons. The material is entirely neutral. The current is due to electron current, and the concentration of electrons is much greater than that of holes. Majority carriers are electrons and minority carriers are holes. In order to form P-type semiconductor, trivalent impurity is added to it. These elements have 3 electrons in their valence shell and need one more electron. These are from group 3 of the periodic table, such as boron, aluminum, etc. These dopant atoms have 1 plus valence electron compared to the semiconductor material. When they are added in semiconductor atoms, they take 1 electron and create holes in the crystal lattice. In P-type semiconductors, conductivity is mainly because of the holes. The material is entirely neutral. The current is due to the hole current, and the concentration of holes is much greater than that of electrons. Majority carriers are holes and minority carriers are electrons.